Okay, so how did the shape change in the graph from y1 to y2? What did it do again? It stretched up and down, right? Yep. Okay, and how did it change from y1 to y3? It smooshed down. Smooshed. Okay? I don't think I spelled it right, but I can't spell it. So anyway, okay. So ladies and gentlemen, so this is again, if you're multiplying the whole function times n and n is greater than 1, it's stretching. Multiply the whole function by n and n is less than 1 but n is greater than 0, it's smooshing. Okay, so it says, we say that the graph of y2 is the image of the graph of y1 under a vertical scale change of magnitude, in this case 3, because we multiplied by 3. Using mapping notation, we can say that we did this to it. Right? You're basically multiplying the y's by 3. Okay. The x's don't really change. It's the y values that are changing on this. Right? Because if you remember, you're still taking the same It's the f of x that's changing. Yeah, right. Okay, so this is the same thing as taking y divided by 3 in our original equation. Now this is weird. When I first read this before, it's confusing at first. But why they're saying that, no pun intended, why, is if I say I'm taking this whole thing and multiplying it by 3, this is the same thing as if I divide both sides by 3, I get y divided by 3, do I not?
Yeah.
Yes, so that's where they get this from. Okay. Using the same function, it says graph the lines of f of x divided by 2 and x divided by 5. Okay. Now, I don't have this, but I'm going to tell you what happens to it.
Wait, can I ask a quick question?
Yes. Uh-huh.
So why, they're referring to y as in like the function, not like...
No, it's just saying that if I were going to talk about... Yeah, this is saying, I'm not, this is just saying, yeah, yeah, it's in terms of y. Okay, now before we did this basically, right, we did 3 times f of x. Okay, now they're wanting us to take f of x divided by 2. Okay, guess what is going to happen?
Guess what there is. Hold on. I think it'll be 2 times 3, which would be 6.
No, okay, so don't say 3. I'm just saying this one right here. What is it? This one we multiplied by 3 and it stretched it. What happens if we divide the x by 2 in the function?
Then it'll smush it down. Wait, I don't get
Which way do you think it's going to change?
Okay, I can't play with this.
Yes, you got it. Before we were doing this, right? Now we're messing with the x itself.
So then it's going to go this way.
It's gonna be a horizontal shift now. It's gonna be stretching horizontally or shrinking horizontally.
So it's going to stretch.
It's gonna stretch this time. It's gonna double the x values for this one right here. I know, and this is the opposite. You're right. So this one is doubling the x values.
Can't we just put it in there? Can't we just put it in our calculator?
Yeah, but okay. All right, so this was doubling the x values. And this one is doing what to the x values? Quintuples. Hey, times by 5. Okay? All right. That's a 5. All right. All right, so what we say that if the graph of f of x divided by 2 is the image of f of x under a horizontal scale, the change is the magnitude of 2.
How do you know? Like, what if it was smushing it?
Can you graph, like, you know when you put it on that scale thingy? Does it automatically graph when you put it on there?
In your cast, yeah, you can make it do that.
Okay.
Okay? All right, so listen. The general scale change centered at the origin of with a horizontal scale factor of a not equal to 0 and the vertical scale factor of b not equal to 0 is a transformation that maps xy to ax and by. Okay?
What does A and B stand for?
A is what we're going to multiply by, okay, to make it stretch or shrink or smoosh. Okay? So, for instance, if A is 1 and B is not 1, then the scale change is a vertical scale change because we are looking at how it's changing the y. The x doesn't change at all. The y is what's changing.
Wait, but if B isn't 1, like, why does that mean that it's
Because then it's going to be like either B can be a 2, what would happen to the y if the B is a 2?
what do you do?
What do you do to B? Does B make it move left
It would
to right?
smush. And if
Wait, so does B make it go like an accordion, and A makes it go?
yes.
Okay.
Okay? So B is going to be affecting the y. So whatever the scale change of this, it will make it either smoosh or stretch. So remember, we were saying that earlier earlier on the page before when they changed it, the y to y divided by 3, Tori? Okay, so right here, that y divided by 3 is same thing as saying as the x divided by 3. This tripled it, right?
Yeah.
Okay? This one doubled it, okay?
So you're saying when A is 1, then x over 1 is 3.
Right. X over 1 does nothing. It's just x, right?
But X over 2 would make it double it and make it go like that.
Right. Okay?
And then Y over 3 would be like,
Tripling it. Tripling the y.
will it
Yes.
make it shrink this way? Up and down.
Nope. It expands it.
Well,
Okay.
yeah, and then it's smoosh.
So let's keep talking and I'll show you some more
What
examples.
makes it smoosh?
If it's multiplying by a whole number.
So if it's like a big fraction form, it's getting expanded, it's just multiplying it.
Yes, so good way of saying it. Okay, so if A and B are fraction form, okay, then it's expanding,
Yes.
or if it's a whole number, if it's greater than 1, then it is smooshing. Okay? Okay, so going back down to our little thing that we're filling out here. If B is equal to 1 and A is not 1, then the scale change is a horizontal change. Because we're dealing with the x, not the y. I can't spell today. Okay? Okay, when A equals B, the scale change is called a size change. Okay, so notice from the activity that replacing x with x divided by 2 in the equation results in a scale change. So that scale change basically is saying that we're going to take the original x, okay, and we are multiplying the x by 2, right? Okay, but the y doesn't change in this case.
Okay.
Okay?
But do we still have to like write it out as a thingy? Like, do we still have to write it out as like a little statement? Probably be best to do so.
Yes. Okay, so if we were to write it out, it'd be like x over 2y, right?
Oh, I should do it that way. Can't you just do 2x?
But you know that it's multiple. Remember, if it's a fraction, this is a fraction, it's expanding.
That
Okay?
scares me. Then just flip it.
Rewrite it by saying 2x. That's like totally opposite.
Well,
Yeah, it is totally the opposite.
2 equals x.
I
and
get
then-
like thinking about it opposite, but how can you write it opposite? Because then it's just like saying the other one.
Yeah. All I can say is this is one of those times in math that you kind of have to memorize it.
Okay.
Okay?
But like, what if you see like size change or scale change like x, y, and arrow, and then 2x? How do you know?
Then you know it's a shrink factor, right? Because it's actually dividing it by 2. I know that's
How do you
goofy.
know that there's a relationship by-
Yeah, so then A is a whole number, right? And if A is a whole number, because say if you said 2x, so then A is 2, then you're going to shrink it. Okay? I know, it's the opposite of what it says, and I don't have a better way to explain it right now. Just have to memorize it, and I'll try to find a better way. Okay, Tori? I don't know. Okay, so the next one, it says, if we replace the y by y divided by 3, what happens to the y?
It goes times
Yes. Okay?
like with 3y.
Y over 3. Yeah, you can do both x and y at the same time.
No, I mean it's like when you write that, like the first one you do 2x and you do 3y.
Or you just say underneath it, just to remind yourself it's really 3y, if that'll help you any. I don't know. All right, so here's the theorem. Okay, so it says, given a pre-image graph, described it by a sentence in x and y, the following two processes yield the same image graph. If I replace x by x over a and b by y over b in the sentence, it'll have a scale change of this. Okay, now I'm getting confused. I want to catch this before you guys get too far. Go back. Okay, go back.
Go back?
Yes. I want you guys to erase this. Or mark it off. Okay, hey, remember last week, please listen. Last week when we added something to x and y, remember we had, say you add 3 to x and you take away 2 from y. Remember how we had t of x, y? Yes. Okay? We're doing the same thing. And remember the original equation, we're doing the opposite. We had to put it in the equation opposite. So say we had y equals x squared. And we did this to it. So it'd be y plus 2 equals x minus 3 squared. Remember that? We had that whole chart that we did last week. Okay, this is the same thing. This is going to be the opposite. We're going to put this into the equation, but on this scale thing, we're actually going to write it what it is. So this should be 2x and y. This one should be x and 3y. Sorry, I got myself all befuddled. Okay, so.
Yeah, that's what I was
Okay.
saying. Shouldn't it be 2x?
Yep, this is it. So here's an example down below. I want you guys to watch with me. This is a circle, correct? Okay, so now we are going to multiply the x values by 2. Yes. Yes.
Yeah. I thought we'd already had that.
Okay.
You just not want us to write x.
Yeah, I want it to be like this. And I'll show you why in just a minute.
And same with the y one.
Yep, same with the y one. Okay, so now, here it is. It says we are changing the x values by 2. We're multiplying by 2. So now look, let's look at the graph and actually physically change it. If I'm at 5, what should the x value be in the new graph? 10. If I'm at -5, where should my x value be? -10. If I'm at -3, where should my x value be? -6. So it's like right here, if I'm drawing very accurately. If I'm at 3, it should be at 6. So basically, this makes a great big eyeball.
Oh, it does.
And I'm not drawing it very nicely, but you can kind of get the picture.
Wait, so we times it?
Yep, because it's scaling the x's by 2. You're multiplying each x value by 2.
Oh, it does make the eyeball.
Isn't that cool? All right, so we graphed it up here. You guys can see what happens. It actually stretched that circle out. Now it says write the equation for the image relation. What we're going to do is just replace the x by x divided by 2. Squared plus y squared equals 25. Notice how this is opposite of this.
Why are you scaring it?
Because it was squared to start with. I'm just replacing the x.
Wait, what are you replacing what with?
The original thing was x squared plus y squared equals 25.
So you replaced it with x over here?
Yes.
Because that's what the thingy is?
Yep.
Okay. Oh.
Okay, so let's talk about it again. If, say I was going to shift this x plus 1, y minus 2. Say that was what I'm doing instead. Okay? Then I would replace the x and y with the opposite of this. So say it would be x minus 1 squared plus y minus 2, or y plus 2 squared equals 25. Remember, we're doing the opposite. If it's a plus or minus, we do the opposite inside of the equation.
Anyone you want?
Yeah, I just threw one out there.
Oh, okay. Will you stop?
Okay? So the same thing is true when we are multiplying by a number. In this case, we got s of x, y, and then we did 2x and y. What if I change this? Let's change this to something else. Let's do 5x. What would my equation be then? Yep, x over 5 squared plus y squared equals 25. Okay, it's always the opposite of what this is when I put it into the equation. Just like up here, when we were adding, subtracting away, we did the opposite of what the translation said.
Is it actually 5?
Yeah, it's 5x, so then I would divide x by 5. All right. Let's look at the next example. It says, without using your graphing calculator, describe the transformation that maps a graph of y equals absolute x onto the graph of y divided by 4 equals 6x. Now remember, this is the opposite. So what would my translation look like? What happens to my x's? Mm-hmm. And what happens to my y's? 4y. So my x's are 1/6 of the original, and my y's are 4 times the original. No, this is already in the equation form, right? So I'm going from equation to this. All right, so on this one, I have this equation. What is my transformation here? My scale factor change? Yep, so it'll be 3y and or x over 2, right? Okay, so let's look at these and rewrite them as to what they're supposed to be now. If my new negative of 6 is going to be what? Negative 3. What's my new y for that one? Yep. Point, what? Of 6. So 2 times 3 should be 6, right? What's negative 3 divided by 2? Or negative 1.5, yep. Okay, negative 2 times 3, or negative 1 times 3. Yep. Okay, 0 divided by 2. Negative 1 times 3. Negative 3 again. 2 divided by 2, 3. No, 2 divided by 2. 1. And 3 times 3. 9. And then 6 divided by 2. 3. And 0 times 3 is 0. Okay, so now what we want to do is draw these points back on this graph and look at the change. Okay, so at negative 3, we're up 6. So that should be...
Wait, what did you do to get other than times divided by 2?
Divided the x's by 2, multiply the y's by 3.
Okay, thanks.
Yep. Okay, so that was the first one. Let's look at negative 1.5 and negative 3. That would be right here. And then at 0, it's at negative 3. That's right here. 1 and 9, that would be up above the graph a little bit. And 3 and 0, right here. So if I could draw it really nice and straight, and you guys, I'm not going to be able to with this particular device, but you can kind of see.
You can like put this on.
I can?
Yeah.
I'll try it next time. Yeah. So what happened to the horizontal scale? It smushed, and what happened to the vertical scale? Stretched it. So that's one of those cases where you have both going on.
So do you start having
Okay, and I have one last one to talk about here, and then you guys can start working on your homework. I'm going to come around and look at your homework. Okay, so this one says the line 41x minus 29y equals 700 contains these points. Use this information to obtain 2 points on the line with this equation. Now notice, how did the x value change? Yeah, okay, so it divided by 2, right? So my s of x, y is x divided by 2, correct?
Wait, where did you say?
Look at the 41, and how did it change here from 41 to 20.5?
Oh, okay, so it's divided by 2. And
Yep.
that one is times by 1.
Times by what? 3, so it'll be a 3y. Okay, so what it wants you to do is to take these 2 points and translate them with the new translation. Okay, so 39 divided by 2 is what? Okay, so that'll be 19 and a half, 0.5. And 31 times 3 is 93, right? Okay, this one, you're going to do the same thing. You're going to take the x value and divide it by 2.
Yeah, I'm sorry, I'm really lost. Where are these numbers coming
Okay, so we're using this translation because we found that the x went from 41 to 20.5. It was divided by 2, right? Okay, so that's what I got here. And then this one went from negative 29 to negative 87, so it multiplied by 3. Okay, so we're taking our x value, dividing it by 2. So 10 divided by 2 is 5. And negative 10 times 3 is negative 30.